direction angles and direction cosines. The direction angles are the angles that a vector makes with the positive x, the positive y, and the positive z axis. So, direction angles are the angles that a vector makes with the positive x, the positive y, and the positive z axes. And we'll call these direction angles. We call these angles alpha, beta, and gamma, respectively. What does the word respectively mean? In that order. I gave the positive x-axis first. So alpha corresponds to the one with the positive x-axis. Beta corresponds to the one with the positive y-axis. And gamma corresponds to the one to the positive z-axis. So respectively in that order. And for this, I can say this. The cosine of alpha, well, I have to say, let's say that A is the vector. So let me put that, squeeze that in here. Let's say A, which has first component A1, second component A2, third component A3. So A is this vector. Then I can say that the cosine of alpha, let me lower that a little bit, cosine of alpha equals vector A dotted with vector I over the magnitude of A times the magnitude of vector I. If you do the dot product, what will you get? You get A sub 1. And how about the magnitude of I? That is 1. That's a unit vector. So this is the magnitude of A times 1 is the magnitude of A. And I didn't write this out, but you know, if you look at this, I'm going to write this on the side. Vector A dotted with vector I is 1, 0, 0. Then you're going to get A sub 1 plus 0 plus 0. You're going to get A sub 1. The cosine of beta is vector A dotted with vector J over the magnitude of A times the magnitude of vector J. Vector J is the standard basis vector that's in the direction of positive y. And this would be A sub 2 over the magnitude of A. And I can write similarly, the cosine of gamma is A sub 3 divided by the magnitude of vector A. So the angles, alpha, beta, gamma, are the direction angles. The direction cosines are right here. the cosine of alpha, the cosine of beta, and the cosine of gamma are called direction cosines. Now, I want to put one more definition of, well, I don't know if this is a definition, but this is projection vectors. If I have two vectors, so I'll say, let's say we have two vectors, A and B. I'm going to draw this in two space. I have vector A right here. Vector B, I'm going to draw a little bit shorter. And they have this angle theta between them. Then I want to project B onto A. And I think of it, you have a light shining up above. It's coming straight down. The shadow of B onto A, where this is a right angle. So I end up with a third vector, the shadow of B onto A. That's called, it's a projection vector. It's a projection vector of B onto A. Vector projection of B onto A is given by, they write PROJ for projection. A is written small, B is written regular size, and this equals vector A dotted with vector B over the magnitude of A squared times vector A. And then we also would find the length of this vector. And I'll talk about that next time. I will tell you